Okay. Hello, good day, everyone. Welcome to today's Skill Up session from DevOps Institute and People Search, powered by Techstrong. I'm your host, Siddharth Parekh, and today we are talking about the SRE chaos engineering. On our panel today, we have Alessandro and Alessandro. So, welcome both of you. And before we get started, I want to let the audience know that this program is live and being recorded so you can view it again for on demand. Also, there are chat and Q&A boxes on the right side of your screen to communicate with the general audience in chat and questions for us, the speakers. Let's start with some introductions. Let me introduce myself first. My name is Siddharth Parekh. I'm part of the NatWest Group. NatWest Group, as many know it, is Banker branch. That is what it is. I'm part of the DevOps Center of Excellence practice, working on many transformations, including the culture aspect, and most importantly, for the per se of this session, the chaos engineering as well. Let's move to the audience before. Let's go to our speakers. Why don't you introduce yourself? Let's start with the Elisandro.
Alessandro or Alejandro?
I think he meant
Okay.
so, one of us. Thank you very much for the to having me. Yes, it's live, so it's a bit exciting. My name is Alessandro Botz. I live in Amsterdam. I'm a CNCF ambassador. That's what I'm proud of. That's my role as a community leader in the Netherlands. I run the Dutch Kubernetes Meetup, a bunch of other communities around cloud native. So really, cloud native and cloud native Complete Foundation is my home. I work at Solo.io. We also do service mesh, and we love to talk about platform engineering and networking, application networking. But yeah, it's an honor to be here, and I'll try to bring the point of view of the Cloud Native Complete Foundation over chaos engineering.
Cool. Thank you so much.
Well, my name is Alejandro with J. Alejandro Mercado. Nice to meet you all. Very honored to be here too. I'm also DevOps Institute ambassador for Mexico. I am also Gremlin Chaos Engineer certified. So I have been in the IT industry for more than 25 years. I started my career as a web developer, but I can say like 7 or 8 years I started doing DevOps, still understanding how to do DevOps, and now chaos engineer. So very honored to be here.
Cool. Thank you, both of you.
Okay.
My first question um, to the US, when we talk about chaos engineering, there are different lenses that we can view chaos engineering as in. Some may think that it is all about breaking things on purpose. Some may think is as bringing some new tool for adoption of chaos engineering, and some may view as in a different per se altogether. So the question to each one of you is, how would you explain chaos engineering from a cultural perspective? Let's start with Elisandro first.
Of course, this is the same. I remember when chaos engineering, when we first started talking about chaos engineering, they came out of course, the bigger organization like Netflix, and of course, like DevOps. And as I see chaos engineering as a branch of DevOps or something very similar to DevOps, so people that do DevOps do use, and it's definitely partly about the tools, right? But it's really much more about the culture, as you say. So as culture is defined as a set of shared values that an organization, a social organization, could be a family or a team or an entire company, share, right? So if we as a group of people share the values of continuous testing and experimentation, then we say that we think in terms of chaos engineering, or we adopt the principles and the values. So for me, it's really what you do. It's more than how you do it or which tool you use, but it's about the practices of adopting this mentality, this mindset of continuously thinking about how a system can break, how system behaves under pressure, how system can react to unexpected situations.
Okay, the unexpected situations. We'll come to that. How about you? What was you think, Alexandro, about the chaos engineering from the cultural per se?
The, it's kind of fun because if you if someone asks you what do you do for a living, and you answer I am a chaos engineer, it sounds like something from a movie. No, you are the villain of the bad guy of a Batman movie. Or if your mom asks you about I am a chaos engineer. But the truth about that is that the chaos is under control. So in the cultural side, I totally agree with Alessandro. Is about the mindset. Is exactly like DevOps. I mean, no matter the maturity level of the company, if they are starting in the digital journey, that they have a lot of expertise, this is a culture that you have to introduce, that you have to nurture. So it's little by little, it's a step, and the tool is just like the logical consequence, but it's about the culture. I mean, it's we are going to try our system if they are how fragile are our systems. So we think that we are bulletproof, but the truth is totally different. I don't know. Yeah.
If I may add, because it's something that it really resonates with me. So I'm a scientist. I'm a scientist by education. I did study chemistry. So chaos has its own discipline of science, right? So there's a chaos theory, and there's a very, very rich and interesting things you can say about chaos. So chaos is also generative, right? So, and it's also where all physical systems tend to, right? So the principle of increasing entropy. I know that I'm digressing, but I really love to expand the talks about what we do is our job. Of course, like we test systems and we deal with complex systems, but in the end, there's always some underlying physical principles about it, right? So chaos is, for me, is a beautiful word. It doesn't mean, sure, if you look at my bedroom or my kid's bedroom, that's the definition of chaos, but there's also something more profound and interesting about chaos, which is also it's a whole branch of science that studies complex systems, how they behave, systems that are so complicated that cannot be described by classical equations, so they have their own behavior, right? So, and then this chaos theory treats physical system as black boxes, and it's very, very similar to what we do with computer systems and distributed system in what we do. But I urge everybody to also like go beyond, you know, that their field and study a bit of physics, of chemistry, and chaos theory.
Is it possible to explain to the the audience out here something about chaos theory that you're talking about, something in layman terms? Maybe a quick
Yeah.
way
So,
of.
and I'm just an amateur physicist. As I said, I'm a chemist by education, but chaos theory deals with untractable problems, right? So untractable systems, they are so complicated. Think, for example, the three-body problem, or very complex quantum system. they have so many variables and so much uncertainty about them that they cannot be studied predictably. There's no determinism about those systems, so you cannot apply the usual very predictable, very deterministic equations. So you need to study in a different way. So you just analyze their behavior and you try to make an educated guess about the physical system. Now, how does it relate to SRE? That's the question, of course. We treat our systems also in a way as a black boxes, right? So we don't assume that we know exactly the behavior of the system beforehand. We set all the observability tools, we look at it in different angles. We apply some pressure there and some other system. We apply some load somewhere, and then we analyze the results. So I think scientific mind and scientific approach it really lies at the core of chaos engineering, but it's my opinion, of course.
Okay. Anything that you want to add, Alessandro, over here?
Yeah, well, from the engineer side, I can say that, well, traditionally we test our systems. So we don't really have like chaos because we do test, unit test, any kind of test that you want to mention, and environment. So we have dev, stage, staging until production, but we don't really know what is going on in the production environment. So you can maybe just think about Netflix, one of the pioneers of this concept with Chaos Monkey. So I can imagine, some engineers telling to the CEO, "We are going to attack our own system." So, well, are you insane? What are you saying? So well, that's the idea that we don't really know on production. These all variables that Alessandro mentioned, but because this is the real environment, real users, real VPNs, real servers, real API gateways, etc., etc. So we like to have things under control, but that's precisely the idea, just to make this hypothesis. They have like some engineer principles that no service should be a single point of failure, but is that really true? So how we can prove it? So well, that's about this is related to the site reliability question. So in terms of we are talking nowadays about observability, it's like a trending topic. It's observability. I think that we are seeing an explosion of these kind of tools. So observability in general is the extent to which you can understand the internal state or condition or a complex system. So the idea is to have end-to-end visibility of what is going on, no matter how many servers, databases, applications. So it can be too complex. So we have many tools to help us to monitor, to observe, and to know to have a root cause analysis. So I think that Chaos Engineer is another tool that is contributing to this observability that we must have.
Okay. I'll come to the observability maybe later. We can talk about a lot of gagas about good things around chaos engineering, but maybe a question which people like may know to is, where does chaos engineering doesn't work, or where would chaos engineering, let's say, would fail? And the reason the question is being asked is uh, because chaos engineering, like DevOps, should not be considered as a magic wand which would improve your observability or availability or resiliency by itself by having this practice. So maybe putting this question first to Alexandro, where do you think chaos engineering would fail or might fail?
Yeah, thanks. I would like to come back to the observability later on, but because it's also something really close to me. So I think chaos engineering will fail and does fail when there is no culture to support it, right? So when there is this blaming culture where breaking stuff is frowned upon, right? So there is this finger pointing and not really curious or curiosity about learning about the system. So it does fail when there is no real culture that supports the principle of chaos engineering, right? So, and then we've seen it. I mean, it's not every organization is mature enough to go to adopt chaos engineering. It's something we should strive for. I mean, if you are in an organization where there is this very political and people are afraid to change and afraid to move things around, then either fight for change or leave. Of course, it's also an option, but every organization should strive for accepting the truth. I think for me it's chaos and it's so interesting because it's about accepting the truth about a system, right? So, and how you know the truth, you have to, like put it to test. And if you are not ready for that, then probably your organization is not ready to really use chaos engineering to the best. So that's probably something you have to ask yourself. I mean, am I in an organization that is able to leverage tools like chaos engineering and DevOps, of course, and many others, and observability to the best, or am I in an organization that is not ready for that, right? So that's my take on it.
Continuing to your answer, you mentioned about the culture. Culture is not conducive enough. Can you be little more elaborate of a quick specific pointers of how do I evaluate whether the culture is conducive it or not? Because what you're speaking, of course it would matter, but from the perspective of chaos engineering, what would be the specific elements, aspects, do anyone need to you know um let's say mature enough in their organizations to start this practice of chaos engineering?
So it's part of the DevOps transformation, right? So it's part of the DevOps culture to also accept failure and even turn failure into something positive, right? So failing is definitely not something you should be afraid of. Everybody says, I mean, it is very known. You're only afraid of things you don't know, right? So it's some uncertainty and the unknown that really scares people. So try out, be bold in your experimentation. Then that's a trait of successful organization where failure is accepted as a part of life, and a part of our job. It's nothing to be afraid of. Nobody should get fired by breaking things, and that means also you can do this controlled chaos, which is chaos engineering. You can use it to really get the bottom of system behaviors.
Okay. Moving to you, Alexandro, what do you think, where would this chaos engineering concept would fail in the organization, or
Yeah,
maybe not able to achieve the intended success, let's say?
yeah. I would like to add something to Alessandro comment. To have time to learn and experiment is very important. So it's part of the DevOps culture, as stated in the Phoenix project. Maybe you have heard about that book.
Yeah.
It's like the DevOps Bible. So this is part of, I mean, if you don't have time to experiment, you can do chaos engineer. So this is in the cultural side. On other side, I mean more technical side, it can be difficult to determine how the outcome was achieved when other factors outside of our control have influence in results. I mean, if you are testing and have another system, or I don't know, other factors, I will say. So which can make it difficult to reproduce effective results. So I think that this is a very common scenario where when chaos engineer it's difficult to determine the outcome.
It's okay. Um, there is one question which is now posted on our QA section is the question is how does agile uh, it's okay just a second, how does agile practice align with chaos engineering? Do you have any answers to this? Yeah, go ahead.
Yeah, am I of course, like, so agile is really like a about continuous delivery of value, and chaos engineering is this continuous delivery of knowledge about the system. I think the two things are go hand in hand, right? So you do want to have your whole organization, all your software development practices built around agile principles. One of them is also, continuously testing if your systems are up to the task, if there's some single point of failure, as Alejandro said. So the two techniques, of course, they deal with different parts of your team activities. One is more about software development and how the team is organized, and one is about the systems themselves. But they do go hand in hand, I think.
Anything else that you want to add to this, Alexandro?
Well, agile is like well, when we do DevOps and start using this kind of tool like chaos engineer, it's like an extension of, I mean, it's part of the same general idea to make better software in shorter times. So it's like the same. Just I mean, I don't see like a difference, but as Alessandro said, it's about instead of getting a new feature, you gain knowledge of what is going on with the system. I am totally agree with that.
I think I have a view also on this is when we talk about agile, we're not talking about any given practice in general. We're talking about quote unquote the agile principles, and that is basis on which you have different agile practices like your Scrum, your like Kanban, or many other practices also. Similarly, in chaos, we are not talking about the tools or the practice or the production system. What we're talking about is more on the chaos principles side. Or more on the chaos principles, you can visit that website. So, in a nutshell, the chaos principles implementation lies in how do you adopt chaos engineering in your organization. Similarly, how do you adopt your agile principles is based on sort of practices that you wish to follow. So that is in short, that agile principles based on which the agile practices are formed, and chaos engineering is based on where the principles have come through. I hope that should answer the question. All right. Uh, Generally, the other question comes up, gentlemen, that to have chaos engineering, we need to have huge investments on our tool. We need to have, let's say, our budgets for them to be ensured to have a chaos engineering. Do you also think so, or do you think, look, for chaos engineering, it is good to have budgets, it is good to have tools, but you can actually start adopting and practicing it even without both of them? What is your view on it?
Well, please go.
Go ahead, please.
Yeah, I think the investment is more in the human side. I mean, you need to practice, you need to experiment, you need to choose a team. I mean, a small team just to prove it and to gain credibility and this is very important to gain credibility, to have visibility the whole business, what we are doing and why, and to communicate the results. But I think it's more about people, about time, about experimenting, budget. I mean, yes, of course there are licenses, but also there are open source tools that you can use to start, and maybe at some time you can adopt another proprietary tooling. But I mean, in terms of people, I think it's a huge investment.
Okay. What is your view, Alessandro, on this?
I do agree. So, they say the best things in life are free. So you really don't need much, right? So there are definitely great open source tools out there. And it's more about how the investment is more about time, right? So time of your team. But no, definitely you don't need to break the bank to adopt chaos engineering. And it's amazing because it's so you can do right now, right? So you just have to make a plan. Don't do it. Don't just go and delete servers or kill stuff in your AWS application, but you should do it properly. But yeah, you don't need much to start. It's just a bunch of engineers getting together and deciding that they want to know more about their systems in a very special way by breaking things intentionally and observing the state of resulting state. So yeah, it's one of the things you can do right now, and you don't need to have. For sure, you need to probably have like the management approval for that, because you don't do shade of chaos engineering. I think that's a bad idea. Like randomly killing stuff without telling your teammates. But something that if you agree, your team is you decided it's part of your values, right? So we want to know more through chaos engineering. I think it's a great thing to start, and doesn't cost anything really.
One of the questions that is asked in the Q&A section, and I think it sort of relates to what we'll be discussing right now. I'll try to, reiterate that question and just call out if you think there's something additional that you want to answer to it. So the question is, can you describe in general how you usually apply chaos engineering to a production system? Maybe is a dummy question, but for me, just come
Oh,
like
no.
complex to build a general pattern. Or do you consider that there is no possible to do that?
There are no dummy questions. So, well, we have several types of attacks. It's about attack the servers. I mean, CPU. You can generate head load. You can allocate a specific amount of RAM. You can attack the network. I mean, block access to then DNS servers. You can simulate latency. So there is an arsenal of attacks. So well, that's why we have a lot of tools that they have this. But the main component of the main idea, if someone want a takeaway, is to have an hypothesis. So start small with, I mean, maybe we are going to test the login component. This is a pretty good hypothesis to prove the login system component, to see how it behaves. If so, we can attack this component, and if it fails the whole system, or just is I mean is not is based on that, you can take decisions about the architecture. If the microservices is not working alone, so we may rethink the whole architecture. But it's about that. It may make hypotheses, just to attack a single part and start, well, little by little, making these experiments.
Alessandro?
Yeah, I agree. So it's not coincidence that chaos engineering really arise at the same time that it comes from Netflix, right? So or at least those were the first to talk about it, because Netflix was also one of the first organization adopting microservices at scale. So want to do chaos engineering on a monolith is probably pretty hard, right? So because you're gonna bring down the whole thing, the whole monolith. But if you have a microservice architecture, as you say, like you have a login service or a card service, try to isolate one service and do chaos engineering on that particular service. The goal is to do it in production, yes. So the end goal is, the end game is we do chaos engineering in production, things are just fine. Clearly, that's not the first thing you want to do. If you have mock-up or some other environments like dev and test, do it there, of course. Gain confidence, gain knowledge, but then the real deal is testing chaos engineering in production. So that's done, currently done by organizations that have reached the level of maturity and the confidence to do that, but it's very possible to do testing in production. But again, having a microservice architecture is probably helped a lot in isolating failures and understanding the cascade of failures that chaos engineering will possibly highlight.
I think continuing to where Alessandro left, it is not important whether you're doing chaos engineering in productions or not, though the ultimate goal or aim could be production. What more important is how structuredly have you done, methodologically have you done your experimentations in the pre-prod or dev environments? And that would give confidence not just to you means whoever is executing the experiment, but the people around also. And that confidence will help you in supporting or driving what you do in chaos engineering. So, when people ask me how you usually apply chaos engineering in production, I say, first of all, I apply it in pre-prods, dev environments, gain confidence of my stakeholders, people, then move to chaos engineering, the production part of it. To answer your question, which probably you would be expecting of, I want to know how you'd really do it in production. uh, you know the easiest answer to this is you just remove your cable of your data center. That's all. That is how you do it. However, a broad answer to this could be you need to have a defined methodology to do these experiments. So you should be knowing what is your state as is looks like, which is the present state looks like, and what are you trying to achieve through this experiments. Point two. Point three is you should be knowing how you'll move, how you should have the rollback mechanism if anything goes wrong. You should also have which are the personas or the people who will be involved and their actions and ownership during these experiments. So more on the how, the important is the approach of doing it in the production environment should be very much clear even before jumping on this. Okay. Uh, the next thing that
If I
comes
may
up,
add,
yeah.
just a little note. So you're totally right. So I think what you need is a mental model of failure modes, right? So having a mental picture of what could go wrong and what the experiment will bring. Document everything. Document before, document during, and document after. So write everything down. So having this mental model, but also be open to change your mental model, right? So because you never know, maybe it's very different from reality what you think about the experiment, right? So as a scientist, I remember when I was in the lab and I was mixing compounds. Yes, I had some ideas. I had built a mental model based on previous knowledge, but it's always you always have keep a open mind to what you can find out from an experiment.
Yeah. I would like to ask, in our case, we follow GitOps methodology, we can have another session about GitOps, but well, the general idea is to have the desired state versus the actual state. I mean, you can break everything, so you can recover just with the manifest. So well, that's like an approach. So totally recommended if you are in this DevOps, chaos engineer world to learn about GitOps or implement a tool but as I said, it can be another talk.
Okay. What happens is, so the question that we have discussed till now is, how does chaos engineering gels up with the culture per se? Where we could start the chaos engineering and where could, where potentially it fails. We've also discussed around how to start chaos engineering without having a budget or without adopting any tool. So how do you think, the next best question could be, how do you think is how do you build culture based on your chaos principles? So I know, Alessandro just touched upon it on the earlier part of answering one of the questions is, now what should I do, and maybe little breakups of step by step of calling it out that, look, this is what steps I need to follow in order to have a environment where I can bring in the chaos principles within the organization. uh, who would like to take it up?
Well, in this case, I have used Gremlin, and they have a pretty clear methodology. I mean, they have everything pretty clear, documented. So how to make an experiment and to follow a path to do some chaos experiment. They even have some servers just to try it. If you want to start with chaos engineer, it's a pretty good idea. But if you want to have your own server with your own tool, of course you can mount your own servers in a free tier in AWS or wherever you want, and just to set up some institute servers with an application and start destroying it and have fun with that. I mean, it's not expensive. You can use the free tier, or even there is a lot of companies that are offering free trials, and then they have like it's pretty clear and defined what you have to do. And as I said, the first thing is to have a hypothesis. Well, what we want to measure, I mean, it's about measure, about observability, no? Within this metric, just to see if the system is resilient, or the anti-fragility of our system. So, I mean, it can be like the common questions. If I'm the CEO or the IT director, I would like to know that. Can we resist an attack? Of which kind of attack? What happened if we lost the access to DNS servers? Of maybe if we kill a process, what happened with the system? Is all the system unresponsive? So that's the way. So to start learning, there is, well, you Google it, and there is a lot of tools and tutorials. So there is no excuse to start learning chaos engineer.
Yeah, I totally agree. Of course, I agree. So the culture is it's a very difficult question, right? So the what is a culture? How do you influence a culture? You can't just make it. It doesn't work this way. You can't just say, now we have this culture of chaos engineering. It's not. People are very unpredictable, right? So they are not computers. The people that operate the computers are the most important part, but also the most difficult to understand. So you can't just say, hey, from now on, this is our culture. No, you have to nurture it, like slowly reward, for example, the people that do embrace your values. Do organize, I don't know, Friday meetings where you do try these things. You reward, you influence the rise of the cultural values. You can't just make it so. It's an interesting discussion. DevOps has been talking about culture for a decade now, and it is the most difficult part of implementation. So the tools kind of easy, right? So you just download them, install it, and maybe it needs some fine tuning, but it is the people that really matter. So that's chaos engineering. I think it's done right, can bring a lot of value, but you gotta do it adopting also the mentality, the mindset of continuous experimentation.
Um, we have some, a bit long question, or I guess it is more of a statement, but anything that you want to add to that statement is. The statement or a question is the Voyager mission required engineers to think very seriously about what if scenarios of the spacecraft, which was indeed had many complexities. Now, it required simulations because it would be too late after launch. Is it not better to think deeply amidst simulating the chaos before developing the product instead of testing in resiliency afterwards, such as chaos engineering testing?
I
Uh,
think
b-
it's a
b-
great.
b- yeah.
So,
Before I jump on to the, this question is, uh, I think little more important is for the audience per se is how do you view, a chaos engineering versus a testing ones? Do you think both are same? Do you think they have a difference? What is your view? And then probably we'll jump on to this question or a statement, which I think so.
um, first of all, let me say that this comment about the Voyager is great because it's probably even before Netflix, the NASA invented chaos engineering, right? So indeed, like you do, especially if mission critical applications like shooting people to space, that requires a bit of of thinking beforehand. And we suggest, like we said, we document everything, think of the experimentation, think of the what you want to find out. But still, for me, is really what changes a lot is when you try for real, right? So you can never you can assume, but as we say, like assumption is the mother of all problems, right? So we don't want to leave out. You don't want to just simulate. You want to really test in real life what's your chaos engineering experiment will tell you.
What is your view, Alexandro, on this?
Well, I remember the Netflix engineering principles that is no service should be a single point of failure, and the second one is never trust that you have done the first one. So based on that, I lost the thread. So
So
what I,
what we were talking about is, do you view the chaos engineering as something very similar to testing, or do you think that there are some different thoughts process between the two?
yeah, thank you. I got the thread now, but I won't remember the two principles. Yeah, it's about that. Just never trust about the that you have done that well and it's bulletproof. So it's not. It's different because we test or we try to test everything,
Hmm.
but not in production. So the main difference of the component is the chaos. Is the random, is the surprise that you are going to gather the team someday, but you are not going to say. Well, you can expect that something is going to happen at the system, and maybe a component is going to have consequences on other components. So the idea is just to be prepared for the unexpected. So when I mean when I run unit tests, I expect the results of the unit testing. I mean, or the end to end, or any kind of testing that we are doing, and static or dynamic testing, is we have an expectation of we are probably know the results, but the idea of chaos engineer is that you don't know what is going on. So that's why this is the main difference, and that is why we have this new set of tools to prove our, or to add to our tool change. We have a lot of tools, but yeah, this is the main difference I can say.
It's okay. Thank you both. I think just to conclude between these two, what they've said is, so when we talk about testing, we talk about the code quality testing, unit testing, integration testing, and most of the testings. And if you see, every testing has an intended purpose, but most of the testing, almost every testing, besides some here and there exception testings, uh, are limited to things before the product goes in production. So before things product goes into production, you have 100 different sort of testings, but you generally don't test when things goes in production, and then you sit, cool, and wait for anything to get failed over, and that is probably then you do reactors and monitorings and other observability aspects of things. Whereas chaos engineering do these experimentations right after when the product has gone into production. So the major difference between testing and chaos engineering is this umbrella, where the testing happens before things goes in prod and chaos after things goes in production. Coming back to the question, gentlemen, about the Voyager mission, what is your view? Is it not better to think deeply and simulate chaos before developing the product instead of testing in resiliency? Uh, what is your view? Alessandro, do you want to take it up, or?
No, so I thought I already answered this, but yes, indeed. So it really depends what you want to do. If you are into rocket science, of course, it's a whole set of requirements. But for me, it's all about the preparation of the experiment. When I was again, I take it from my experience as a chemist. We had to really write down everything, like the amounts and the procedures, down to the minute details. So we, as a chemist, as a scientist, you don't leave. You try not to leave anything to improvisation. So when you when you reason about systems, you try to predict behavior. But for me, it's really nothing beats real life experience, like real life. So as you said, testing, of course we've been testing software for the longest time, but what you do is you test things in isolation. You test a part of a software, and chaos engineering is a kind of a different beast. You unleash chaos, right? So you purposefully and intentionally disrupt the system, and you measure the behavior, the response. So that's a very different kind of testing. It's not a unit test. It's not a synthetic test. It's something really, really more comprehensive, and it's you say is a higher level of knowledge and understanding about the system.
Interestingly, I don't see any questions left unanswered in the Q&A sections, which shows that we have been going pretty well of taking up and picking up the questions from the our audience. Uh, I think one of the things that we were discussing earlier, and I think that you talked about of this very specifically, Alexandro, was around observability, around chaos engineering. Do you wish, spend, a very quick short while to let our audience know, is there any relationship that exists between observability and the chaos engineering?
Yeah,
Um,
definitely. Well, go ahead, please.
Uh, just so because of course I'm from the Cloud Network Foundation. Just so you know, I mean it's very interesting. Open Telemetry, which is one of the projects within the CNCF, is actually one of the is the second largest project in CNCF after Kubernetes. That means there's a lot of people really looking into observability as a tool to understand behaviors and then how a system work. So observability is crucial. Don't do any chaos engineering if you don't have already a very accurate depiction, a very accurate image, or you capturing all the metrics that matters to you about your system. So it would be like flying blind or using all these beautiful chaos engineering tools and doing everything correct. But then if you don't see what's going on, you are like it's completely useless, right? So observability goes hand in hand with chaos engineering, is really complementary. By the way, observability is not monitoring. Is observability really means the ability of a system to be observed, right? So, and that's when you start looking into observability, you realize how important it is for a system to be observable, right? So, built-in metrics and logs and all the places that you can observe a system is very important. So, not only of course capturing those signals, but also making the system more observable, more open to be observed, right? So that's the core of observability for me, right?
Yeah, can I add something?
Yeah, please go ahead.
Yeah, observability is about logs, metrics, and traces. So definitely to have another tool so we can ingest more data to these observability platforms, it's going to be something. I mean, the more data, more logs, more metrics, and more traces, so we can get more insights of what is going on with the system. So we can get a root cause analysis, multidimensional analysis, etc., etc. So there are pretty sophisticated tools to do that. So in combination with another tool, of course, any chaos engineer tool by itself has dashboards, but I mean, if it's part something that is like a tendency is not to have like 7 or 8 tools to independent tool because you're making silos. So it's you have something to monitor the network and something to monitor the database. And I mean, like the what we are seeing today is like one tool to gather all the information and you make dashboards on this tool. So the whole business, no matter if you are a tester, developer, or a QR, or even the CEO of the company, have visibility of what is going on with the system. So the idea is, in conjunction with this chaos engineer tool, integrated to a observability platform, can give you an enormous advantage. So can give you more visibility and to resolve problems, to avoid war rooms, and well, you mentioned so yeah, and we have this another aspect of AI ops. So we have, I mean, there is going to be a point of that there is no enough humans to manage all the system and the complexity. So we are adding artificial intelligence to help us to give up the problems, so to help us to not just to detect. We can solve, the auto healing of some systems. So yeah, it's completely part of the same game. It's like a puzzle, so you can integrate the pieces totally.
Okay. One of the questions that is asked in the our Q&A section is, how do you build a business case of having chaos engineering in the organization? So, uh, how do you like to have it? How do we create a supporting material or article or a slide deck of calling it out that look, chaos engineering is good for the organization. How do you sell it is probably the question is.
Yeah, I have to leave very soon because the room gets crowded very soon. But so I will suggest this to sell chaos engineering to your management. Tell them that it's going to happen anyway, right? So chaos is part of life, is part of our systems. Things break, things go down, cables get disconnected. Somebody trip over a cable. Nowadays, it's more, of course, in the cloud, so people do delete instances by mistake. The cloud itself go down. I mean, nobody will sell you 100% of uptime in Azure, AWS, or GKE, right? So instances do go down in the cloud. So why not preventing them or embracing the chaos by studying it in isolation, in a controlled fashion, and then when it happens, you already know if climate change is real, right? So there are floods, there are tornadoes, and more, and there's going to be more. So there will be cases of entire availability zones in AWS or Azure going down, being offline. So why not studying that before it happens instead of last minute panic reaction to disasters? And I don't know if you agree with. I mean, we see this, right? So this is a real thing. There will be more extreme weather events, just to name a few, right? So think about that.
Right. Alejandro, maybe some last words before we wrap up for the day.
Yeah, well, as a DevOps consultant, this is a pretty common question. How to adopt DevOps? I mean, I think it's very similar. How to adopt chaos engineer? It's pretty like the same. Try with a small system. Try to gather a small team. Measure everything, give visibility just to gain credibility. Just measure, and transparency is the key to see what is going on with the system, what are the improvements, what are metrics. It's about metrics, and metrics are the blood of the SRE. So it's in the DNA of the SRE. So it's about, I have these numbers, and after doing these experiments, we improve the latency, or the component, the response. So with numbers, you are going to give it to your CEO, and you are going to get a rise. Well, they are going to gain credibility to implement in the whole organization. But yeah, the idea is to start small and give transparency, communicate results.
Cool. I think we had some great, interesting discussions happening, and we have taken almost every question that was asked in the session today around chaos engineering. So, with this, thank you everyone for joining us today to consider uh, the relationship management and project successes. And a very big thank you to our panelists, Alexandro. Next up in the DevOps program is the Cloud Security DevOps, DevSecOps, on Thursday, November 2nd. The registration page is pinned in the chat. Please go ahead and show your interest if it likes to be. With this, thank you so much, both of you. I hope you had some great good time with this. Cheers. Goodbye.
It's been a pleasure.
Thank you. Cheers.
Thank you very much, and hope you have a great day. Bye.